An odd function is a function where algebraically, if you plug a negative x in to the function for all of the variables, when you simplify that negative x out, every single term in the expression will change to the opposite sign. Okay, so I'll show you what that means in a minute, but you plug in a negative and every single term has to change for it to be odd. And an odd function, graphically, is symmetric to the origin. So if you're starting at the origin and you have 4 on the graph, so right and up, then you can go left 4 and down 4, and that will also be on the graph. I'll show you like a little trick to trying to tell graphically if it's odd, but just quick summary. An even function. Okay, an even function is like the parabola in the parent function of the parabola. Now this is when you plug in a negative x into all the x's, and every term goes back to the original x squared, or every sign, basically your initial signs stay the same after you plug in negative x because all the negatives like squared out. And this even function is always symmetric to the y-axis. Okay, so the left side is a mirror image of the right side. So that one's pretty easy to tell just by looking. So algebraically, like I said, if you plug a negative x in, then every single term in the function is going to change to the opposite sign. An even function, when you plug in a negative x, will just go back to the original. So none of the signs will change. And then neither just means some signs change and some don't. So it's an all or nothing thing with this. So you can have a function that's neither either nor odd, neither nor. And this would be some signs change, but some don't. Some, but, oh, I almost wrote but with 2 T's. That would have been a little embarrassing. Sorry. Some, but not all. I'm recording this. This is, oh God, I'm trying to have to edit this out. Some, but not all signs change. Oh God. All right, so let's try some of these algebraically. So what we're doing is we're plugging in a negative x, that's the test. If all the signs change to the opposite, it's odd. If all the signs stay the same when you compare it, then it's even. And if some change and some don't, we're neither. Okay, so for letter A, we're finding f of the opposite of x, or f of negative x. Did I skip something? I didn't, right?
No.
Okay, just want to make sure. I just heard lots of papers turning, I just want to make sure I didn't go too fast. All right. Okay, so we plug in a negative. And then we have to evaluate the parentheses out. So a good way to think about this, I'll show you a shortcut as well as we go a little further, but negative x cubed means we have negative x times negative x times negative x. I'm just going to leave that part the same for a second. So that's like negative 1 times negative 1 times negative 1, right? Here, negative times negative times negative. Won't that stay a negative? Mm-hmm. Right? So negative would stay. We don't want parentheses anymore. And then we have x times x times x, which is x cubed. Okay. And then negative 6 times negative x is plus 6. And so what we want to do, so that's fully simplified, there's no parentheses. So what we want to do is we want to compare this to the original. The x cubed sign changed to a negative. The x term changed to its opposite, right? So didn't both signs, yeah.
Why does negative 6 times negative x equal just 6?
Awesome. Thank you. Appreciate that. Sorry, guys, I was just thinking about the negative and the negative. Thank you, that does not go away. Appreciate it. So the signs changed to both their opposites, right? The cube term became negative when we plugged in negative, and then the first term changed to a positive. So that makes it an odd function because every single term changed. So odd function. All signs change to the opposite. So that's what it looks like for an odd function. Every term has to change from the first to your new evaluated function. So let's do it again with letter B. So it's always, you're plugging in the opposite of x, that's the test. Okay, so let's plug it into both these. So we're gonna have negative x quantity to the fourth minus 2 negative x quantity squared. So you can expand this out, right? That means we have negative x 4 times. And then we have negative x twice. If you have an even number of negatives, don't those all cancel out to a positive, right? Because every 2 would cancel to a positive, so positive, positive. So that is going to go back to being x to the 4th. Because the negatives will all cancel out because it's raised to an even power. And then just remember that you can't take x's away. So if you started with 4, you're going to end with 4. Right? So we still have x to the 4th, but it went back to being positive. And then minus 2. And then we have negative x times negative x. That's going to be a positive x squared. Right, so that negative in between doesn't have to change because negative x times negative x was x squared. So bring that minus 2. So compared to the original, all the negatives canceled out. So that is an even function. Okay? If the function is the exact same, unchanged, that's even. Try to do letter C, see what you come up with. Okay, plug in the negative, re-simplify it, and then see if you can designate it from there. you'll note that here, right, the negative x squared, you can expand it if that helps you see it, or you can think of it as this, a negative to an even power. That's going to be an even amount of negatives, so they'll cancel out, right? So if it's to an even power, the negatives will cancel. And then so that goes back to just being x squared. So that one, no sign change. But when I plug a negative x in here, there's nothing for it to cancel out with, so it's going to make that a minus 2x. So that's one sign change. And then a constant is never going to change its sign, because it doesn't have a variable attached. So this is going to be neither, right? Because some signs change and some didn't. Just want to see if there's room somewhere. Do you guys have a little room underneath that work for me to just add in one column? Okay. I just want to add in one thing just so I can make a clear distinction. Say we have, just add another example. We'll make it this, if I can get my board to work. So just try to do that one real quick for me. See what you can come up with, and I'll catch up. So, right, so hopefully it may be starting to recognize we have a negative to an odd power. So it's going to be a negative left over, right? So this sign is going to change. Because you have a negative times a negative, only two will cancel. So this will change to a negative x cubed. So we have one sign change here, right? And then when you plug a negative in here, right, that's going to change that sign. So we have another. We don't have a sign change with a constant. You're never going to have a sign change with a constant, right? A constant means there's no variable attached. It stays constant. So an odd function will never have a constant because a constant won't change, right? So this is neither. You want to say it's odd at first, but you can't because that sign didn't change. So an odd function, if you see a constant at the end, it's not going to be odd because that will always stay the same. Okay, so this is neither. And you might just want to note somewhere. I know I put it in the instructions here. The sign of every term changes, so that means every term. So when you're comparing, don't leave out the constants because that is a comparison you need to make. So odd functions can't have constants. so lastly, I'm just gonna show you how to look at these graphically. An odd function, like I mentioned at the very beginning, it's symmetric around the origin. They also say about, that just means like around. So, you know, it's gonna be a function, like, if you think of any of the odd functions that we know, you know, if you have something that's positive and positive, it's gonna also be negative and negative. So the easiest way to tell is to take a look and then flip your paper upside down. And if it looks the exact same, like the same ends are going up and the same are going down, and it's not up or down at all on the y-axis, you'll be able to tell that it's odd. So if you flip it upside down, it's the same exact picture. And I'll show you, I'm gonna flip my screen around a little bit. And then an even function is a lot easier to tell because that's gonna be the one that's symmetric over the y-axis. So that one, as long as the left side is a direct reflection of the right, then that's gonna be even. Okay, so let's look at some of these so you can see what I mean. All right, so number one, we know that that's not even because the left side is not a reflection of the right. Okay. Now, to tell if it's odd, we want to see if, you know, it's exactly the same when you flip it upside down. Okay. And sometimes you can just tell by looking. Like, I can tell it's not going to be symmetric about the origin. Just because, like, see, 2, 4 is on here, -2, -4 is not. So you can tell that way by just finding a point on the right side and making sure the left side has the same one but the opposite, or we can flip it. Okay, so right now it's going through -3 as its y-intercept, and the right side's going up, the left side's going down. So if I flip it upside down, yes, the right side's going up and left side's going down, but you'll notice my y-intercept isn't down at -3 anymore. It went up to +3. So you see how you can flip it upside down and check as well? All right, you just check a couple of the little pieces that won't change, and you'll be able to tell. All right, looking at number 2, and it can't be more than one thing. It's either going to be even, odd, or it's just neither. So this one here is just neither, because it's not even or odd. Again, we just check the symmetry. Symmetry is just if it's symmetric about the origin or over the y-axis. There is no symmetry here, so this is neither. All right, taking a look at number 2. Is that going to be an even function? Is the left side a reflection of the right? Yeah. Right? If I took this left side and flopped it over, it would lay right on the right side, right? You know, and also you can tell by the points, if you look, all right, -4, 5. Does the right side have 4, 5? Yes. So it's going to be going right over the y-axis, so it would have the same y-coordinates for the equal left and right sides. So again, it can't be more than one thing, so if you notice that it's even, it's done. Number 3, even? Yes. Right, the left side is an exact, again, you could flop it over. Right, if you folded your paper, it would flop right over. All right. Oops. I should write that. All right, number 4. That's definitely not even, right? The left side is not a reflection. But let's see what happens when I turn it upside down. Okay, it's going through the origin. The right side's going up, the left side's going down. If you see it upside down, right, it's going through the origin, right side's going up, left side's going down. So that does have symmetry about the origin, so that is odd. Okay, so if you flip it upside down, it's the same function. Again, it's odd. Try to do the last 2. Okay, so 4 is odd. Try to do 5 and 6.
So if the function doesn't have like 0, 0 as the y, then it's not going to
It could be, it's more rare, but let me show you an example. So, you could have something that has a face into it, so that would work, but it's so rare you're gonna see that, but yeah, because if you flip that upside down, it's
It
gonna
would
be
be,
the same.
okay.
Yeah, but most of the time it will go through.
But if
the
it's
filter.
just one line.
Yeah.
then- okay.
Yeah. So what'd you guys find for number 5? Odd, good, that's gonna be odd. Remember we said that there could be no constants with an odd function? That's because graphically, if there were constants, it would be at the end of the function, it'd be like a y-intercept. So it'd be like up a couple or down a couple. When you flip that over, it's gonna go opposite. So it's not gonna be the same amount up or the same amount down. So that's also shows here you cannot have a constant with an odd function. It's just not gonna work. All right, what about 6? Neither. Excellent. All right, cool. All right, before we get to the homework, I added a couple problems that I want you guys to try. Just algebraically, I just want you to plug in the negative and simplify it out and decide. If you guys could just do, let's see. B, C, and E. So try B, C, and E. I'll go over them in just about 5 minutes. And then I'll give you your homework.